Hi everyone, let's open up to lesson 10.5. We're going to talk about diluting the solutions. So here we are given two sodium chloride solutions. Both of them have 2 moles of the solute, as we can see. And the only difference is in the first one, the 2 moles of the solute are dissolved in a 1 liter solution. And in the second one, they are dissolved in a 2 liter solution. So if you go ahead and calculate the concentration here, molarity is equal to the moles of solute over the liters of solution. So we have, for solution A, we have 2 moles per 1 liter of the solution. That gives us a 2 molar solution. And in the second one, you've got 2 moles of the solute per 2 liters of the solution, and that gives you a 1 molar solution. So what this tells us is that as water is added, the concentration of the solution goes down. However, as you can see in this in the 2 diagrams, the number of moles of the solute remain the same. So let's take a moment and recall how to do some calculations with molarity equation. Predict how many grams of solute are required to make 1.5 liter of 4 molar solution. So take a moment. So once again, the molarity equation is moles of solute over liters of solution. So if I go ahead and plug in the things that are given to us, we have 4 moles of the solution. We are looking for, we have a 4 molar solution. We are looking for the number of moles, and we have 1.5 liters of the solution. So to calculate moles, we can multiply 4 times 1.5. That gives us about 6 moles. However, the question is asking for grams, so we can go ahead and multiply 6 moles with the gram formula mass, or the molar mass of sodium chloride. So 1 mole of sodium chloride, because sodium is 23, chlorine is about 35.5, so sodium chloride together is about 58.5 grams. So then we can just plug this in the equation. You end up with about 35.1 grams of solute. So that means to make this 4 molar solution, we're going to need 35.1 grams of sodium chloride. So let's say you go ahead and you have already made this solution, and now you are asked to dilute the solution. And the new solution that you want is supposed to have a concentration of 0.5 molar. So take a moment and just predict, what would you do to dilute this solution? What are some thoughts? So the way we actually do this is we use the stock solution that we just made, which is defined as the solution that we begin with, basically. So solution with standard concentration and again, this is what we start with. And then the process of diluting this is called a dilution. So this is the process of creating solutions with new concentrations using a stock solution. So if we want to use that 4 molar sodium chloride stock solution and create 0.5 molar diluted solution, let's derive an equation here. So as we said earlier in the do now, both of these solutions are supposed to have same number of moles. And so before I write this, remember, according to the molarity equation, which is molarity is equal to moles over liters, a symbol for, actually, we can just do it this way. So if both of them have same number of moles, so moles of solution 1 is equal to moles of solution 2, then if I rearrange this equation, then moles is equal to molarity times liters. That means the molarity of the first one and the volume of the first solution is equal to molarity times volume of the second solution. So this is the equation for dilution, where M1V1 is equal to M2V2. M1 and V1 are supposed to be for the stock solution, and then M2V2 is supposed to represent the molarity and volume of the diluted solution. And we have already answered this question, that the dilution does not change the number of moles. So if I go ahead and plug in the numbers for this problem, M1 for our stock solution is 4 molar, and we need to figure out how much of that stock solution do we need to make a diluted solution, because I am given the molarity of my new solution as 0.5, and I'm given the volume of the diluted solution as 100. So when you do the math, 0.5 times 100 divided by 4, you get about 0.00125. Actually, 1 second, let me do this again, because I think this might be in, okay, 0.5 times 100 divided by 4, that's 12.5. So we are going to need 12.5 milliliters of the stock solution, and we are going to mix that with enough water to make a 100 molar solution. So that means step 1 is to get 12.5 milliliters of stock solution, and step 2 will be to mix with enough water to make 100 milliliter solution. So let's do some other problems. So over here you are asked, how can we use a 4 molar stock solution and make that 100 whey? This is the same question. You can, it's okay if you answered this earlier, but I'm just gonna go ahead and move this down. Totally okay, you do not have to rewrite this. Totally okay if you wrote this at the top. Okay, and then the second problem here is how do we make 250 milliliters of a 0.2 molar solution from a stock 1 molar solution? Once again, actually take a moment to work this out, then I'll show you the work. So here's my M1V1 equals M2V2. M1 is, remember, it's supposed to be the stock solution, so the concentration of the stock solution is 1. We need to figure out the volume of this. The concentration of my diluted solution is 0.2, and we multiply this with 250 milliliters. So 0.2 times 250 divided by 1, that gives us about 50 milliliters. So that means when we are making this, because the question is also asking to state a procedure, so we are going to get 50 milliliters of the stock solution and mix with enough water to make 100 milliliter solution. So the key thing here is we always add the solute first, and then we figure out like how much water can we add to make the diluted solution. So normally the equipment that we use to dilute the solutions is called a volumetric flask, and it looks something like this. It's got a narrow tube at the top and then like a round bottom, and it's always labeled. It's marked for 100 milliliters or 50, however much it can contain. So what we normally do is we go ahead and get the stock solution in there first, and then we pour enough water up to the mark to get whatever amount of solution we need. If we don't do that, if we accidentally, or let's say if we decide to put the water first and then put the stock solution, and at the end it ends up being above the line, then we have to restart the whole thing. And we don't want to do that. So always put the solute first and then put enough water to get up to the line. So sometimes we can also do serial dilutions, which is when we don't stop at just one diluted solution. We start with the stock solution and then make the first dilution, then use the first dilution to make the second dilution, then use second dilution to make the third. So this is called a serial dilution, which is a series of dilutions. Okay, series of dilutions using the stock solution. And for the only difference is that every time we are doing a new concentration, then our previous dilution is called our previously diluted solution is now the new stock solution. And so aliquot is the specific amount of the stock solution that we use every time. So this is the portion of stock solution used for dilution. So here you have an example of a serial dilution. So suppose you start with a 100 molar stock solution, you take a 1 milliliter aliquot of the 100 milliliter solution, and then add about 9 milliliters of water until the total volume is in the new test tube is 10 milliliters. You repeat this process a total of 4 times. What is the concentration of the final solution? So go ahead and use your M1V1 equals M2V2 equation to figure this out. Okay, so let me go ahead and write it down. So for the first one, this is your solution number 1, or let's say dilution number 1, dilution number 2, dilution number 3, and dilution number 4. So for the first dilution, the stock solution is 100 molar. And then we need to figure out the volume. Actually, they already told us that this is 1 milliliter. So this is 1 milliliter. What we don't know is the concentration of the new solution, the concentrated or the diluted solution that we have made. But we do know that we made 10 milliliter of the new solution. Okay, so now let's solve for x. You have 100 divided by 10, that is 10 molar solution for the first one. And then in the next one, now we are going to use that 10 molar solution to do the second dilution. So now our stock solution is 10. We are going to use 1 milliliter of the stock solution, put this in, and then make a 10 milliliter solution. So now 10 divided by 10, we get a 1 molar solution. Oops. And then using this for the third dilution, we have a 1 molar solution to begin with. We are putting in a 1 milliliter sample, 1 milliliter aliquot, and then X for the concentration, and we are making 10 milliliters of the diluted solution. This gives us N2 as 1 divided by 10, which is 0.1. And then lastly, we're going to use that 0.1 molar stock solution. Take a 1 milliliter aliquot and then make a 10 milliliter solution. So now the concentration of the final diluted solution is going to be 0.1 divided by 10, which is 0.01 molar. And this is how you do the calculations for your serial dilutions. And that's it for lesson 10.5. I'll see you in the next one.